So in this video, we're going to be practicing graphing trig functions, specifically for sine and cosine. And we're going to do different things to it. Like we're going to add some vertical shifts. So you can see there's a plus k here, or anything that's adding or subtracting to a function generally causes it to shift vertically. So just as a quick reminder, we have some vertical shifts here. And we are also going to change the amplitude. And the amplitude is the number, or this A, which represents a number in front of the sine or cosine. And I do want to mention that the amplitude describes the length of how tall or how stretched out your sine or cosine graph is. And because it's describing length, we always want to keep that positive. And so make sure if you're asked to find the amplitude that you always write the positive value for amplitude. So that's why I have the A, or the amplitude, in absolute values. Another thing I want to mention is the sometimes the coefficient, or the A, the amplitude, might have a negative sign, right? So if you have a negative A, what happens to it is it will flip the graph. And I think you guys have seen this before. You guys might remember, if you are in Algebra 2, if you have x squared and you have a negative sign in front of it, instead of having a parabola right side up, you have a parabola that's pointing downwards. And it's the same thing that will happen on a sine and a cosine graph. Instead of it being the normal way facing, it will just flip across the x-axis. And we'll see that happen here. But I want us to look at these graphs, make a table, investigate what that graph is going to look like by plotting those coordinate points from the table, and then stating the amplitude, period, and midline. All right, let's get started, guys. For the first one here, we have sine, and it's a 2 sine x. And so that means this 2 here that's in front is our amplitude. So I already know, without even graphing, my amplitude is 2 because it's a number in front of my trig function. And just to keep in mind, I have a positive 2 here. So if this was a negative 2, it'd still be a positive 2 for the amplitude, because amplitude talks about the length. Now, the next thing I need to do is figure out what my graph looks like by making a table. And once you get really good at this, you might not need a table anymore to make a graph. Now, it wants the graph to be from 0 to 2 pi. And so if I were to draw this graph here, or make this table, let's make sure we include those x values. So I like to plot 0, and then pi over 2, pi, 3 pi over 2, and 2 pi, just because it gives me enough data points to work with to have enough coordinate points to graph. So I usually choose about like 5 points at least to graph my x and y values. Now I'm going to plug these values in for x, for sine. So this is going to be 2 sine 0. So if I were to go to the unit circle at 0 radians for sine, let's just go real quick. So grabbing a unit circle here to look at, we can see that at 0 radians, the sine value here, or the y value, because sine is always connected to the y value, is 0. So instead of sine 0, I can just replace that by what it equals, which is 0. And I can do that for the next one. When I go to sine of pi over 2, that y value for sine pi over 2 is 1. So at this point, I want us to get really good at knowing what each trig is going to be without looking at the unit circle here. So sine of 0, like I said before, is going to be 0. And so that's just going to end up being 2 times 0, which is 0. When we have sine pi over 2, well, pi over 2 on the unit circle, sine pi over 2 is just 1. So this is just 1. So 2 times 1 is 2. And if you're asking me why am I multiplying the sine number with the 2, well, it's because they're sitting next to each other. So this indicates a multiplication. And I just wrote in parentheses to imply multiplication. The next one here is going to be plugging in pi. So sine pi, well, if you look at the unit circle at pi, the sine value is also 0. So this is going to be 0. Sine of 3 pi over 2 is negative 1 for the y value. So this is going to be negative 2. And then we're going to go all the way back to 2 pi. So sine of 2 pi is 0. 2 times 0 is 0. And I've completed my table. So I'm ready now to graph my equation. And I'm only needing to graph it from 0 to 2 pi. I draw a coordinate system. I need to make sure I have enough to scale. So I might extend this down a little further. So this goes from 0 to 2 pi. Again, I like to half it and then just half it from there to get the other pi over 2 and 3 pi over 2. And so I need to scale my y-axis, and what I do is find the lowest y value that I have, which is negative 2, and the highest, which is positive 2. So I know I only have to go furthest down, negative 2, and furthest up, positive 2. From here, I can plot my points. I have 0, 0, so that's the origin I'm starting off with. At pi over 2, I have it at positive 2. And then at pi, it's back to 0, so back down. And then at 3 pi over 2, it's at negative 2, so further down. And then back to, when you have 2 pi, it ends up going back to 0 for y. So it goes up. And notice how I'm curving because I know this is a sine graph, so I want to curve the best I can. There we go. And so what I notice about this sine graph is that it's being stretched to 2 instead of 1 this time. If you compare it to the first sine graph that we made, it's being pulled upwards to 2 and downwards to negative 2. And so I can see that my amplitude here, if I go from the highest point to, looks like right here is the midline because this is about 2 up and 2 down. So this would be considered the middle point of the midline here at y equals 0. So I have my midline at y equals 0. And it's about 2 units up, 2 units down to show the amplitude. The period here, I can see that one full revolution where I go up and I come back down for my, so I have like a maximum and a minimum that shows me one revolution, and I notice it's from 0 to 2 pi. So again, the period here is 2 pi. For this section, all the periods will just be 2 pi. In the next lesson, we'll talk about shifting the pi's. I also want to mention that when we're looking at a sine graph, you'll notice kind of like this S-shaped curve, in a way like a snake-shaped curve. Whereas, let's look at a cosine graph now. So this cosine graph, there is a vertical shift. And anytime there's a vertical shift, the midline gets shifted up. So generally, the midline is always at y equals 0. But if there's a vertical shift like we see here, so we have this +1 here, vertical shift, up 1. So this is going to show me that it's going to go up by 1 unit. That means our midline is going to go from 0 to +1. So if it was a -1, it would shift down. But in this case, it's a +1 here. And we're going to notice that when we actually draw it. Now we're going to make a table so that way we can investigate what our x and y values are going to be. So x values, I always keep it the same as 0 to 2 pi, and then just every half a pi. So pi over 2, pi, another half a pi, so 3 pi over 2, and 2 pi. So I like to make sure there are 3 points, or 3 x values and 3 y values. And so I'm going to be plugging these x values in and figuring out what is my y value. So I have cosine 0 plus 1. Now I have to find what 0 is for cosine on the unit circle. And remember, cosine is related to the x value. So if I go to the unit circle at 0, cosine of 0 is the x value, which is 1. So I'm going to need my x value, 1. When I go to cosine of pi over 2, the x value there is 0. And then I'll go to pi, my x value is negative 1. And when I go to cosine 3 pi over 2, the x value is 0. And if I go to cosine of 0, the x value is back to 1. So I kind of foreshadowing what all my cosine values are going to be. So here I go. So cosine of 0 was 1. So this is going to be 1 plus 1, which is 2. Cosine of pi over 2, that's when cosine pi over 2 is where the x value is 0. And so I have this part 0, but I have a plus 1 here. So that's going to be a 1. And then I would just do the next one. So cosine of pi is where cosine is negative 1. But then I have a plus 1 here. So I'm going to have to add this to positive 1, which ends up being 0. And then cosine of 3 pi over 2 plus 1. Cosine of 3 pi over 2 is 0, plus 1 is going to be 1. Cosine of 2 pi is 1. So when cosine is 2 pi, if I add 1 to it, I just get 2. And now I have my x value and I have my y value. So once I have my y values, I can use those as my coordinate points. So the first coordinate point I have is 0, 2. But let's make our graph here first. So I need to draw my graph. So this is from 0 to 2 pi. I'm going to half it and then half it again. Pi over 2, 3 pi over 2. And so my highest y value is 2, so I'll go all the way up to 2. My lowest y value here is at 0, so I think this is all I need. Okay, so I have 0, 1, and 2 on my y-axis. Looking at this here, before I even graph it, let's see if we can answer any more questions. Like the amplitude here is the number in front of the cosine. So I want you to notice that the amplitude here, or the number in front of cosine, is just 1 technically. So I can already foreshadow that my amplitude here is going to be 1, positive 1. My period is probably going to be 2 pi, but we'll check in this case. So plotting these points, this is 0, 2, which is right up here. And then at pi over 2, it's 1, right about here. And then at pi, it's 0, so down back here. And then 3 pi over 2, it's back up to 1. And then 2 pi, it's back up to 2. So if I were to draw a cosine curve, a cosine kind of looks like a U shape. So I'm going to try to form that U shape again by making those curves and connecting the dots, but also curving at the same time. So I get kind of that U shape. And when I look at this here, I notice like typically when you look at the original cosine function, it dips down to -1, but it's been shifted up 1. So the midline is actually right here. So our midline is at y equals 1. Which makes sense because we shift it vertically up 1. So instead of it sitting at 0, it's sitting at 1. And if I choose this up my midline, notice that the length between the lowest point to the middle, or the midline here, is the same distance for the midline to the highest point. So this amplitude right here, this length, I'll just put amplitude, is 1 unit. It's going from 0 to 1, so I know that's 1 unit. Same thing from this point to 2, that's about 1 unit. So these distances are equal to each other. So I know that this has to be the midline. So that one is for part B. Let's check out part C next. So before I can answer, draw a graph or make a table, I know that this one is y equals -3, and that -3 is a number in front of sine. So that tells me my amplitude. But my amplitude is always positive, right? So if I stick this -3 into an absolute value for my amplitude, it's going to be +3. So my amplitude is +3. That tells me the distance from the midline to the top and the lowest point is about 3 units away from the midline. I also noticed there's no vertical shift here. There's not a +1 like we had in the other equation. So this midline's probably at y equals 0 because there's no vertical shift. All right, next step is to actually draw this graph. So let's start making a table. Oop, that's a little bit big for a table. So I have my x values and my y values. And again, I'm going to choose the same x values I've been choosing. So I try to go every half a pi. So 3 pi over 2 and then 2 pi. And so I'll plug this back into my equation here. This be negative sine of 0. That would give me, let's see, sine of 0 is just 0. So that's going to be 0 when I multiply it by -3. Sine of pi over 2 is where the y value is +1. So that's -3 times 1, which is -3. Sine of pi, so when you have sine of pi, that is when it's 0. So if I multiply, that will just give me 0. Sine of 3 pi over 2 is where the y value is -1, or when sine is -1. So -3 times -1 is +3. And last but not least, we have sine of 2 pi. So when sine is 2 pi, that is when it equals 0 for sine. And so if I multiply it by 0, I just get 0. All right, so if we were to draw a graph here, extend this a little bit. So we're going from 0 to 2 pi. Again, just going to half it. And it looks like my highest point is 3. So I'm going to graph it all the way up to 3. And my lowest point is -3 on the y-axis. I noticed I had a -3. So starting at this coordinate here, I have 0, 0. So that's the origin. It's pretty easy to plot. At pi over 2, I have -3. So I actually go down this time. And which is interesting because usually sine starts at the origin and then goes up, but this one went down first instead. Let's keep that in mind. And then at pi, we have it at 0, so back to the x-axis. So it's going from like down here and then back up if we were to connect the dots. Then at 3 pi over 2, it's going to +3, so up here. And then for 2 pi, this is going to be at 0. So coming back down. And there we go. We have our graph. So if you compare this to the normal sine graph, I'll kind of write here to the side. If you guys remember, the normal sine graph goes up, back down, back up, and it has from -1 to +1, and it crosses at pi. So this one is the normal sine graph. This one's kind of inverted, where instead of going up, it goes down first and then up. So anytime you have a negative coefficient in front of your trig function, it causes it to flip. And so in this case, that's why the graph flipped on us. The period here, we can still see that this is the one revolution. It goes down and then back up and then back to 0. So this is one revolution still, and it goes from 0 to 2 pi. So that's our length of the revolution. Or if you guys don't know what revolution means, it just means cycle. So we can see it completes its cycle in 2 pi's of the length. All right, in the next video, we'll try out the practice problems.